Begins the classiest screencast I've ever done. So this screencast is called I Sharded. This is talking about a computer science term called sharding, which is spelled with a D. Now, I think I need to get something out of the way. So sharding is a homonym. A homonym is when a word sounds like another word that is spelled differently for something a little bit different, and it means something different. So the first time I ever brought up sharding in class, I was teaching Cisco ACI, and the APIC cluster uses sharding as part of its HA. So I used the term sharded, and everyone started laughing, and I couldn't figure out why, and it took me a few seconds, and I realized, oh yeah, that's right. There is a term, and this is the venerable Philip Seymour Hoffman talking about the term in the movie Along Came Polly. So I just want to get that out of the way, get your chuckles in, and of course I use it for the comedic timing for the or comedic effect for the title I sharded. So let's talk about sharding. What does sharding mean? Sharding is a scale out methodology. So what does that mean? So if I've got in terms of being able to scale and it being able to handle more and more capacity or serving up more and more capacity, we have the option to scale up or we can scale out. Scale up means building bigger and badder servers, and scaling out means building more. So what if you have a database? What if you have, for example, an encyclopedia? So I've got an encyclopedia that has A through Z, or A through Z if you're in Europe. And, pardon me there. You've got that encyclopedia. Now, if you actually had an encyclopedia that was one volume of A through Z, that would be a really big encyclopedia. It would look something like this. And to open it, it would be pretty much unwieldy. This is what it would look like. Artist rendering. So of course we don't do that with encyclopedias. And encyclopedias are probably the best example in the real world of sharding. Now, some of you probably have never actually seen a physical encyclopedia. I'm hoping that you've been to a library and you've seen one, and you know that they have them in separate volumes. So they're alphabetized by subject, but they are sharded out into separate volumes. So let's do A through H, I through N, O through Z. Now, I don't know if that's actually good distribution, but let's say that is. So A through H, I through N, O through Z. So if you want to look up airplanes, you're going to go through this volume. If you want to look up something that begins with, India Ink, you would go to this one. If you want to look up zebras, you would go to that one. So we're sharding the database. We're sharding the database here. Now, in most computer science, we have three levels. We have sharding, we have replication, and we have placement. So if we're going to shard a database, we're going to have sharding, we're going to have replication, and we're going to have placement. Because databases, of course, and I don't mean just a database like a MySQL database. I mean configuration databases. For example, again, the Cisco APIC cluster uses sharding to shard the configuration database into multiple objects, and then it also uses replication and placement. Facebook, for example. Facebook is a huge distributed database. How do they handle that? Well, they don't build bigger servers. They just use a lot of servers, and they shard. So every database cluster is only responsible for a small portion of the actual Facebook database. So let's talk about replication. So A through H, we're going to replicate. Now, traditionally, we've often experienced replication where it's active standby. So if you have some sort of controller cluster, we'll do active standby. Now, modern replication is at least 3 times. Why 3 times? Well, let's go to the movie Minority Report. So that was the Tom Cruise movie a while ago, and the title was called Minority Report. And the minority report was you had these three precogs. So they were they had precognition. They would see crimes that would happen in the future, and they would all provide a report. It would come out in a little like egg thing. Now, sometimes you would have one of them would give a different value than the others, and that was the minority report. Another example is recently, it was Ivan Pepelnyak had a blog post talking about never take 2 chronometers out to sea, take 3. Because, so let's say we had 3 pieces of data, or 3 replicas of a piece of data, and it was 2 bits. So 1, 0, 1, 0, and let's say they disagreed. Now, actually, let's do this. Now, if you had 3 pieces of data, or 2 pieces of data, you had a replica. Okay, now I've got a backup. So if this one were to die, then no problem. But what happens if you have a disagreement? You don't know which one is telling the truth, which one is actually correct. One of them had an error, but you don't know which one actually had the error. So you should at least do 3, so that if I had 1, 0, 1, 0, and 1, 1, 1, 1 is the minority report. So this one would get thrown out, and we would re-replicate based on these two, with the assumption, the likely assumption, that these two were correct. Now, sometimes I get asked, like, what happens if you have three that disagreed? Well, then you're kind of screwed. So anyway, we have 3 replicas of every shard. So this would be O through Z. So now we've got 3 replicas, but we're not done yet. Did that replica wrong. We need to place them. We need to place them in places that make sense. So let's go over here. We're going to redraw this here. So we have our main configuration, or main database, and then we're going to shard it. So this is the database layer right there. This is the sharding layer. This is the replication layer. And then we're going to have the placement layer. So the sharding layer, so I did A through H, I through N. And then O through Z here. So I've taken the database and I've split it up into 3 different shards, and then I'm going to replicate. So this is A through H 3 times. Now, some of these sharding engines will actually do scrubbing. They may call it something different, but kind of a common term is scrubbing. And what scrubbing means is we're going to check the consistency of these replicas to make sure that they all match up. If we find one that differs than the other 2, then that's the minority report. We throw it out, we re-replicate. Now, I've got my replication layer here. So now I'm going to need to do placement. So I'm going to need at least 3 places to put these replicas. So this is replica 1, replica 2, replica 3. Replica 1, 2, 3, 1, 2, 3. So I'm going to put replica 1 here. I'm going to put replica 2 here. I'm going to put replica 3 here. I'm going to put replica 2 here. I'm going to put replica 1 here. I'm going to put replica 3 here. I'm going to put replica 3 here. I'm going to put replica 1 here and replica. I've completely messed this up. Let's walk this one back. Replica 2 here, replica 3 here. Replica 2 goes here, replica 1 goes here, replica 1 goes here. Replica 3 goes here, replica 3 goes here, and replica 2 goes here. So now, it kind of messed that up, but you get the point. Every place has a replica, has a unique replica. So this one has A through H, it has I through N, and it has O through Z. So I can lose any place, and I still have at least 2 replicas. So actually I can lose any 2 placements, and I'll still have no data loss. And so as long as I have at least 3 placements, I'll have no data loss. Now, if I put in a 4th placement, that works too. But now, actually, let's walk this all back. So let's say I had a 4th placement. So in that case, I'll use a different color here. I'll use green. Replica 1 goes here. Replica 2 goes here. Replica 3 goes here. Replica 1 goes here. Replica 2 goes here. I'm doing round robin in case you haven't noticed. Replica 3 goes here. Replica 1 goes here. Replica 2 goes here. Replica 3 goes here. So you notice replica placement 1, 2, 3, 4. Placement 1 only has 2 replicas. Placement 2 and 3 have 3 replicas, and placement 4 only has 1 replica. And that's just how it works out. So we can have more than 3 placements. I can lose any 2 placements, and I'll still have no data loss. So we have the database, we have the sharding layer, we have the replication layer, and we have the placement layer. Now, this provides us redundancy, this provides us scalability, and let's say I need more scale. Well, I can increase the shards. I can, instead of going A through H, I can go A through D, and then split it into 4 shards, or 5 shards, or 6 shards, or 26 shards, or I can even go through the second letter in the name of the subject. So I can shard as many places as I want, assuming that I have a sufficient number of objects. So like an encyclopedia is perfect because an encyclopedia will have tens of thousands of entries. So that means we have tens of thousands of potential shards. 3 replications at least in order to provide a minority report. And then we have the placements. Now placements depending on how many nodes you have and how many places you want to do things. So with the database, we have the shard, we have the replication, and we have the placement layer. Now, another great thing about this is that another concept that we have. We either have memory or we have algorithm. So what's the difference between memory and algorithm? A memory, if we're going to rely on memory, we have to have a lookup table. And that's where we remember that, oh yeah, zerba, let me fix that. Zebra goes into shard number 3, and aardvark goes, or airplane, goes into shard number 1. So remember we have A through, I always forget which one I got, A through H. We have I through N, and we have O through Z. So this is shard 1, shard 2, shard 3. So zebra goes into shard 3, airplane goes in shard 1. We have to have a place to put this table. And then every time we get a request, we have to do a search of the table. The bigger the table, the longer it takes to do that search, the more clock cycles it takes to do that search. However, if we go algorithm, we don't have to remember anything. So we know that if it begins with an A, well, it goes in shard number 1. If we know that it begins with an N, for a network, let's look up the concept of network. Well, we know that's in shard number 2. So easy. Algorithm is how we're doing most of the database replication or database scaling out these days. Everything from in the computer world, in the IT world, for example, take the Ceph project. So Ceph storage. When an object gets written to, it's going to have many Ceph nodes in a Ceph cluster. How does it know where to send the write? Well, it actually uses an algorithm. It hashes the name of the object and then through that hash algorithm, we know where to send it to. Or take Cisco's APIC cluster. So we actually use an algorithm to determine where to send, how to shard and where to send the placement of that shard. So placement typically gets done by algorithm. So that's the concept of sharding. I hope you enjoyed my very classy description of the term sharding. And check me out on Twitter at tburke, and you can find me blogging at datacenteroverlords.com. Thank you for watching.